Hello and welcome to today's problem, Basic Calculator 2. So given a string s which represents an expression, we want to evaluate the expression and return its values. And the integer division should truncate towards 0. Okay, that makes sense. We have a couple of examples over here. We have 3 plus 2 times 2, and then 3 divided by 2 here, and 3 plus 5 divided by 2 over here. Now, first thing that we should probably think about is that we should take a look at these spaces over here. So we want to probably first keep in mind that we want to skip over these. So skip over white space over here. Now let's actually take a look at the constraints as well. We can see that s consists of integers plus and minus, asterisk and divide, and s has to represent a valid expression, so we don't have to check for any scenarios where it isn't. And then as well as this, all the integers in the expression are non-negative integers in the range 0 to 2 to the power 31 minus 1. Okay, that makes sense. Now that we have all of that out of the way, let's think about like some potential ways that we could do this. So what I'm thinking of is that we could have like a result variable. We want to have that first of all. We also want to have some sort of way to differentiate between these different expressions, right? Now, we know because of order of operations that the asterisk has to come in first, right? And same thing with the division. They're both of equal precedence. So I think like the best way to do this problem would be to separate it into multiple cases. So we can have case 1 if it's an asterisk, right? Let's say like we're looping through every single value in the string. Let's say case 1, it's an asterisk. What do we do if it's an asterisk? We have to figure it out. Same thing with this. 2, division. 3, adding and subtracting, and then finally we want to have a case to figure out like when it's a number. So we'll have like a number value as like a character over here. So like is number. Now with this one, we also want to be able to check from here. We want to figure out how to put this in the right operation before we're able to perform the calculation effectively. Let's think about this. One way that we could do this is we could have some sort of variables which keep track of what the last evaluated expression is along with our current number being like our current number in the sequence. So we can say like, for example, for 3 over here, this is our current number. We know our current number is going to be equal to 3, right? And then, okay, actually, let's for current number, we're going to have a current number to 3. We also want to have some sort of last number or last evaluated expression in order to see what that last evaluated expression is, right? So we can use it and manipulate it. So from here, what we also want to do is we probably want to keep track of what the previous sign is as well. So we want to have like a sign variable over here. What we can do is we can go ahead and think for all of the following cases here, given these values. We can think if it's a number, then we want to probably add that to our current number because like we want to just see if it's like a 32, we want to add that as part of our current number. So what we can do is if it's a number, then we can check to see, we can add to our current number the extra digit. So we want to do current number is equal to current number times 10 plus the integer equivalent of our current character or like value. So that's going to be what's going to happen if it's our current number, just pretty much adding it as like the digits as it goes along. So for example, if it was 32, multiply this by 10, make it 30, add 2, and then it works like that. So next possible case we have to consider, let's actually do the asterisk first. If we have the last number, we want to probably multiply it with the last number evaluated because we know the multiplication operation is going to happen across all of like the last number being evaluated effectively, like the last expression that's evaluated, because we wanted to apply across everything. So we want to have the asterisk be last number times equals the current number because we want the current number in the sequence, right, the 3, being multiplied with whatever the last evaluated expression is to return the proper result. Same thing with the integer division. We want the last number to be divided by equal to the current number. And then for the addition and subtraction, actually we can think about this in its own case here. So we'll have like addition and subtraction here, and we can think about for what we want for this case. We want to add, right? We want to add the current. We first want to add the. We want to determine when we're going to be adding it to our result in the first place, right? Like our result variable is going to be up here. So I think a good place to do it would be if it's like a plus or minus, right? And the reason why I'm saying that is because if you have like the plus and minus over here, and you have like, let's say like this is already evaluated, like this is like 3 plus 4, right? And then like you want to add these together. If we come across this and then we know that our previous sign is a plus, we can add this as part of the final result. So we know that the previous sign is going to be updated for every single time where we encounter a character like this, or like basically like any of these characters, right? So we want to see if the previous sign is a plus, we want to add 4 to 7, and we want to add that to the final result. Now we can come across a scenario where it's like a 4 times 3, right? We want to have like this one, and we want to add our last number, our last evaluated expression, which is going to be 3, and then we're gonna want to multiply that with 4 here, right? And as we multiply, so we're gonna add it and we're gonna multiply it by 4 over here. So I guess what I'm trying to say is that we want to keep adding, we want to keep updating the last number and have that as the last evaluated expression, while simultaneously keeping track of the current number. And then if it's an addition, we add it to the result. And then if it's like a multiplication and the division, then we're gonna want to have that as part of our last number, or like a last evaluated expression, so to speak. So in the case of like the plus and the minus, we want to add to the result the current number being added, or like the current. We actually want to add to the result the last number evaluated, and then from here we want the last number. We want the last number to be equal to the current number if positive, or like the previous sign was a plus, or if sign is equal to the plus. Otherwise, what we want to do is we want to have it be a negative. So we want to do this, else negative current number. So we want to add the last number to the result, and then then check to see if the last number we want the last number to be equal to the current number if the sign was a plus. Otherwise we want it to be like a negative number. At the very end of this, we want to actually keep track of the sign. So we want the sign to be a plus, and then we also, or not sign to be a plus, we want the sign to be whatever the current value is, right? Because if it's like a number, we want to just we don't want this to update the sign, but for every other scenario we want it to update the sign. And then we also want to set the current number to be equal to 0, so it's going to reset the operation, because for every single operation that we encounter, we want the current number to be restored back to its original state. And for the last number, we want that to be our current expression so far that still has yet to be evaluated. And then at the very end of all of this, we want to also check to see whether or not the number was let's see, we want to add to the result, we want to add the last number being evaluated, because we want that to be basically carry on from all of the previous operations. Also need to also check for this. We only want these to happen, these scenarios to happen, if this is if it's not a valid digit and it's not a white space and it's still within bounds. So we want the asterisk, the division, and the addition and subtraction to happen only if these criteria are fulfilled. Otherwise, if it's a number, we want to keep adding it from here. So if that sounds like a valid solution, I'm going to go ahead and begin coding this up now. So we'll have first of all, we have our res to be equal to, we'll initialize all these numbers with 0. So we have res equals current number equals last number to be equal to 0. And then we have our sign to equal to the plus sign over here. Now what we want to do is we want to check to see for every single character or INV in the string, we want to check to see first, is it a number? So if v.is numeric, then we want to add that as part of our current number. So we want to do current number is equal to current number times 10, like we were saying earlier, plus the integer equivalence of our value. Now, the next thing we want to take a look at and see is if it is a asterisk or a division, right? So we want to do if elif, or actually before we want to do that, we want to check the cases here, if it's not a valid digit and if it's not a white space. Well, I guess this already kind of takes care of that operation. Or we want to check to see if, okay, because like we want to keep having it continue on. So we want to check to see if not v.is numeric and v not equal a white space, and the length of the string, or -1, we want to see if the index is not equal, or actually we want this to be or if it's equal to the very last string. That's going to be like a sort of like a case we want to look out for. Then we want this to also occur as well, right? Yeah. Or if the length of I is equal to the last digit, then we want to have this run as well for like the very last number, because we want it to be evaluated. We want to check to see if the number, or if like the v is equal to an asterisk. What we want to happen is we want to have the last number to be equal to the current number. Otherwise, if v is equal to a division, we want this to be last number to be equal to the integer equivalent of last number divided by the current number that we've encountered, because it's being added as we go along. That's going to be our current number. And actually we want to have the current number be equal to 0, just to have it kind of set, like reset every single time. And we also want to have the sign to be equal to the character at the very end of this. Or like we want to have the sign equal to the current value at the very end of this if this happens. Yeah. So yeah. So from here, what we want to do is we want to check to see if the v is equal to a plus sign or v is equal to a minus sign. And if it's equal to any of the two, then we want to have the res plus equal last number, because we want to like add the last evaluated expression to our final result. And then what we're going to want to do is we're going to have the last number is going to be current number if sign is equal to a positive, else we want to have that to be negative current number. Okay, so now that we've done that, we want this to occur, else. Yeah. And then from here, what we want to do is we want to check to see sign is equal to v. Yeah, current number is 0. After that, we wanted to add, like we said, we want to add the result with our last number. And then we want to return our final result here. So just if we go ahead and do a dry run of this at the very end, just to make sure that's valid. Let's start off with like an expression here. So we have 3 plus 2 times 2. I'll put this over here. So we start off with our result equal to 0, current number equal to 0, last number equal to 0, and then we start off and we have a sign equal to the plus as well, to the plus, because that's what we want to initialize it as a positive value first. So we start off, for the first character, we come across 3. Now, is 3 a numeric? Yes, it is. So we initialize the result, or like the current number, to be equal to 3, and then we move on. So we have the current number equal to 0. We reset the current number to equal to 0, and we have the sign equal to v. There is this, like, the sign. Oh, that's another thing I actually want to check. We actually don't want to check to see if the current character is this one. We want to check what the previous symbol is. So we want to have this one to be equal to the sign. Yeah. So sign equals this, sign equals this, sign equals this. Yeah. So at this point, we'll have 3 here, and we have like a current number is equal to 3. Yeah, a current number is equal to 3. I think we'll actually have this to be, we'll only want to have this. Yeah. We only want to reset the current number and have the sign set to the V if it's not a numeric. So we want this to be continuance. So for this one, now we're gonna move on. We're gonna move on and we're gonna have this equal to, the current number is gonna be equal to 3. We're gonna move on to the next number and we're gonna update, it's a sign, right? We come across a sign, we check to see, we add the sign with our last number over here. And our last number isn't actually anything, it's a 0. So we just keep on moving on. And then we set the last number to be equal to the current number. So we said, well, we know what the current number is. We know it's 3, so we're going to have this be equal to 3. Then we move on here. This is our last evaluated expression before the actual sign itself. So before the sign is 3, so we know what the previous value is going to be equal to 3 over here. We move on again, we hit it 2, and since our current number is equal to 0 at this point, right, because it's equal to nothing, we add this. So this becomes 2, and then we move on forward again. Now we hit the asterisk. And now, what do we want to do with our asterisk? We want to multiply it with our current number, because our current number is 2, right? And because the order of operations comes first with this asterisk, we want to multiply it with this 2, and we want to have this expression become 4, right? And that's exactly what's going to happen with our case. Last number times equals the current number, and have it equal 4. And then, now what's going to happen is we're going to move on again. We're going to move on again with our pointer. So now at this point, our last number, because it got multiplied, the last number is going to be equal to 4 here. And then we're going to like basically reach over to the very end over here. Our last, yeah, so our last asterisk is over here. We encounter like the 2 again, right? That's when it actually begins, like the multiplication option. So that's when the last number becomes 4 and the current number is equal to 2. And at the very end, what's going to happen is it's going to check to see for here, it's going to like finish the iteration over here, because like that's going to be a current number. It's going to move on forward, and then we start off here. And then at the very end, we want to add to our results the res plus equals the last number. Do we want to add plus equals the last number? Oh, okay, I see. Yeah, so we wanted to add the 3, like we want to add the 3 to the very end of this. Yeah, because our last number is going to be equal, our last number was previously equal to 3, and then it got added, like this got multiplied, so we got 3 times, this became 3 times, let's think about this actually, let me think. Yeah, our last number got multiplied times equals, and it got multiplied with our current number. And we know from our current number, okay, let's kind of like backtrack a little bit. So here, last number is 3, current number is 2, move on, asterisk, we change the sign to an asterisk symbol over here, and then for the asterisk, the last number is multiplied by the current number. And we know that the last number here is 3, and the current number being added is 2, so we want this to be equal to 6. And then current number is reset to 0. And then we move on to this one again. We have this one. Oh, wait a minute. No. What am I talking about? We have the last number equal to 3, and then Yeah, current like so we have sorry, I'm getting a little bit confused. We have the last number equal to 3, and we have a current number equal to 2. Our current sign isn't an asterisk because it's not being updated. It's updated at the very end. Our current sign is a plus, and if it's a plus, we add that to the result. So res is plus equal to the last number. So this becomes 3. And now our last number becomes the current number if the sign is a plus, which it is. So it becomes 2. That's our last number. That's our last evaluated expression. Else it becomes negative current number. So at this stage, at this point our asterisk is finished, we have the current number equal to 0, last number equals to 2, and then we move on forward as the asterisk changes, like the sign changes to the asterisk. Now for this final one, we're going to check to see if the sign is equal to an asterisk. We want the last number to be equal to 2, and we want to multiply that plus times equals the current number, and that's going to be equal to 4. And at that point, that's going to be our last evaluated expression over here. And now we're going to add this to the result at the very end, res plus equals last number, and it's going to be equal to 4, 5, 6, 7. So 7 is going to be our final result here, which is what we want, times 4, 5, 6, 7, and that should work for our algorithm. So if we go ahead, okay, never mind. 5. Why is this 5? Let's see. Oh, it looks like it's missing the last case. It's missing an edge case here times. Oh, we want to keep adding the sign regardless, actually, even if it's numeric. Or actually, no. Huh. Are we missing something here? Let's see. Int last number divided by the current number. Yeah, right. And if it's a numeric, we want to probably add an else statement, I think, to this. Huh. Wait, no. Let me think, let me think. Last number is equal to current number. Can we add the current number instead? Oh, oh, we can just remove this, and then we can kind of move this in here because we only want it to happen if it's doing this. Because we want it to not just continue, we want to keep on moving to the next one, and then for this one, we want to have it only fulfill this criteria before it moves all the sign stuff. So if we run this, should work at this point. Oh, okay, I see. So I think what's going on here is you have the continue here. You want to remove that, and you want to move this here because, like, if it's a numeric, we only want to have this and like not have the current number equal to 0 or any of that kind of thing. I thought it would work by just doing the continue forward, but that doesn't do it. You have to make sure that the sign is only done this if it's not numeric, and if it's equal to the white space, because that's an edge case that you can miss. So run this again and submit. Okay, looks like it works. And yeah, the time complexity of this one is going to be O of n for every single character in the string, and the space complexity is going to be O of 1, I believe, because you're not actually storing anything in space here. So yeah, thank you guys for watching.